Let us now look at the equation of a plane passing through 3 points. So this is the third way in which we can write the equation of a plane, which is if you know 3 known points on the plane, you can write the equation. So basically, this point A has a position vector A bar and coordinates x1, y1, z1. For this point B has a position vector B bar and coordinates x2, y2, z2. Point C has a position vector small c bar and coordinates x3, y3, z3. Now, P is a general point whose position vector is r bar and coordinates x, y, z. Now with this information, I can derive it very easily, the vectorial form and the Cartesian form both. So for vectorial form, what you do is, you take this vector AP bar, which is r bar minus a bar, because AP bar is OP bar minus OA bar, OP bar is r bar, because it's the position vector of this point P. OA bar is a bar, right, position vector of the point A, so r bar minus a bar. Similarly, AB bar is this and AC bar is this. Now, the thing is, AP, AB, AC, these are three vectors, AP, AB, AC. These are three vectors which are coplanar, right? They are coplanar. So, I can say box AP, AB, AC is equal to 0, right? This was the condition for three vectors to be coplanar. We've already seen this in properties of box product, right? If these three are in the same plane, then their box product has to be 0. We've already seen this, right? Simply, I will use that result to write this. Basically, AP is, so this is basically AP dot AB cross AC, right? So I'll just substitute AB, AC and AP, everything together, and we'll solve this. So basically, when you open up this cross product, inside, then what you get is this, right? And after you finally take the split this, so basically box product is distributive, right? So I can do this dot this part minus this dot this part, and that minus I've taken on the other side, and finally we got box ABC, right? So this is all after simplification. I'm not simplifying it for you because by now you must be already thorough with a lot of things. So when you open up this, and this is the final result that you get after all the simplification. This is your final result. So you have a plus sign in the middle. I forgot to write it here. This plus sign is there, right? So as you can see, this P is represented by R, right? So every point will have its own R. So all those R's which when I put here satisfy this equation, those R's will lie on this plane, right? So this is basically the vectorial equation of a plane. So this is also the vectorial equation of a plane. Now the thing is, it's not looking like this. It's not looking like r bar at n cap equal to d. But when you open this bracket, when you open, put the values and open it up, you can always create it in this form. You can always simplify this in this form. But remember, this is also the vectorial equation of a plane. This is also the vectorial equation of a plane. Just that the scenario here and the scenario here, the way you derived it is different, but they are both the same, right? So this is the vectorial equation of a plane, because every r bar, what is equation ultimately? Every r bar which satisfies this is, you will collect all those r bars, and those collection of r bars is basically your plane, right? All those points, the collection of those points is your plane. So this is basically your vectorial form. Coming to now Cartesian form. So Cartesian form, the thing is, your r PA bar, PA bar is very simple to derive. So PA bar is nothing but r bar, which is xi plus yj plus zk. This is your r bar. And a bar is nothing but x1i plus y1j plus z1k. So when you subtract r bar, so when you do r bar minus a bar, PA bar will be in fact a bar minus r bar, right? A bar minus r bar. So this is your PA bar. If you do this, you'll get OA bar minus OP bar, which is your a bar minus r bar, right? So when you actually substitute, when you put those values, you will get this vector x minus x1i plus y minus y1j plus z minus z1k. What is this? This is your r bar minus a bar, right? Similarly, you'll have this vector, and we already know box product ultimately, when you put in the values, when you actually get this BA bar also by similar means, and finally when you take the box product of these three vectors, I can write them as a determinant, right? So if you remember, AI plus BJ plus CK, in fact A1i plus B1j plus C1k, A2i plus B2j plus C2k, and a3i plus b3j plus c3k. If I take these three vectors, and if I want its box product, what I will do is I'll do simply a1, a2, a3, b1, b2, b3, and c1, c2, c3. Right? This is what the box product will be. So here also I'm doing the same thing, just that you first need to write PA bar the way I wrote here. Similarly, you need to write BA bar, you need to write CA bar, and then when you get all those three in this form, you will simply take the box product, right? And this box product is determined by this determinant, and this box product has to be 0, so this determinant also has to be 0. When you finally expand this, you will get, when you expand this particular determinant, you will get ax plus by plus cz equal to d form. You'll end up getting the equation from this in this form, right? So ultimately this determinant also will give you the equation of the plane. So this is also the equation of the plane, but in the Cartesian form. So with this, we are done with the equation of a plane passing through 2 points. Let's move on to the next topic.